Video 63. Problem number 3. Prove by induction that 1 into 3 into 5 up to 2n minus 1 divided by 2, 4, 6 up to 2n is less than or equal to 1 by root of n plus 1, n greater than or equal to 1. Numerator, every term is increased by 2, 1, 3, 5, etc. Denominator also increases by 2 only, 2, 4, etc. There are n terms in the numerator, n terms in the denominator. Proof. Let P of n be the statement 1 into 3 into 5 etc. 2n minus 1, nth term. And then here you have 2, 4, 6 etc. 2n is less than or equal to 1 by root of n plus 1. Then P of 1 is the statement 1 only in the numerator, 2 in the denominator, less than or equal to 1 by root of n is 1, 1 plus 1. P of k, replace n by k, 1 into 3 into 5 up to 2k minus 1 divided by 2 into 4 into 6 up to 2k is less than or equal to 1 by root of k plus 1. P of k plus 1 is 2 into 4 into 6. P of k plus 1 is one term in the numerator will be extra, that is 1 into 3 into 5 etc. 2k minus 1 into next term we have to increase by 2, you will get 2k plus 1 by 2, 4, 6 up to 2k, one more term extra, that is 2k plus 2 is less than or equal to 1 by k plus 1 becomes k plus 2. So now we have to go to the basic step. We want to prove 1 by 2 is less than or equal to 1 by this is root 2, 1 plus 1 is 2. Now what is the connection between 2 and 2 is greater than or equal to root 2 implies taking reciprocal 1 by 2 is less than or equal to 1 by root 2. This is 1 by root 2. So 1 by 2 less than or equal to 1 by root 2. Therefore P of 1 is true. You know 2 is always strictly greater than root 2. 2 it is approximately 1.414. P of 1 is true. Induction step. Assume that P of k is true. That is 1 into 3 into 5 etc. 2k minus 1 by 2 into 4 into 6 into 2k is less than or equal to 1 by root of k plus 1. Say call it as equation number 1. From this we have to go to pk plus 1. So these two terms are extra. So multiply both sides by 2k plus 1 by 2k plus 2, which is a positive quantity. 2k plus 2 both sides by, which is a positive quantity. when you multiply both sides by a positive quantity, inequality is retained. 1, 3, 5, 2k minus 1 by 2, 4, 6 up to 2k into 2k plus 1 by 2k plus 2 is less than or equal to 1 by root of k plus 1 into 2k plus 1 by 2k plus 2. This is number 2. But actually in this place we should get 1 by root of k plus 2. So now to prove that this quantity 1 by root of k plus 1 by root of k plus 1 into 2k plus 1 by 2k plus 2 is less than or equal to 1 by root of k plus 2. This is what we want to prove. So if we prove 3, then combining 2 and 3, this is less than or equal to this is less than or equal to that, so we will get p of k plus 1. So what you want to prove is this. So that is to prove that since all of them are positive quantity, squaring both sides 2k plus 1 whole squared by k plus 1 into 2k plus 2 the whole squared is less than or equal to 1 by k plus 2. Squaring both sides of 3. If we prove this one, from this we can conclude this, because all of them are positive quantities, nothing is negative. So that is to prove that 2k plus 1 the whole squared into k plus 2 is less than or equal to k plus 1 into 2k plus 2 the whole squared. That is to prove that 2k plus 1 whole squared is 4k squared plus 4k plus 1a plus b the whole squared into k plus 2 is less than or equal to k plus 1 into expansion 4k squared 2 4 8k plus 4. So that is to prove that multiplying 4k cubed plus 8k squared plus 4k squared plus 8k plus k plus 2 less than or equal to here 4k cubed plus 8k squared plus 4k squared plus 8k plus 4. Cancel 4, all of them are positive. 8k squared cancel with this 8k squared, 4k squared cancel with this 4k squared, 8k cancel with 8k. What is the balance now? That is to prove that k plus 2 is less than or equal to 4k plus 4. 4k plus 4. So taking to the other side, what happens is 3k plus 2 is greater than or equal to 0. 4k cubed plus 8k squared, 4k squared plus 8k plus k plus 2. Here 2 2s are 4 2s are 8, 4k cubed 8k squared plus 4k squared plus 8k plus 4k cubed 8k squared 4k squared 8k. So k plus 2 is less than or equal to. So that is to prove this is 4k plus 4k plus 4. That is to prove that 0 is less than or equal to k 3k 4 minus 2 is plus 2. So since k is greater than, which is true, since k value is greater than or equal to 1, k value is greater than or equal to 1, this is k plus 2 4. because when k value greater than equal to 0, hence because this is true, etc., therefore 3 is true, hence 3 is true. Combining 2 and 3, 2 is true because from pk we have obtained it. Combining 2 and 3, 1 into 3 into 5 into 2k minus 1 into 2k plus 1 whole divided by 2 into 4 into 6 into 2k into 2k plus 2 is less than or equal to this in turn less than or equal to 1 by root of k plus 2. Hence therefore p of k plus 1 is true if p of k is true, p of 1 is true, p of 1 is true. Therefore by induction p of n is true, p of n is true for all n greater than or equal to 1, for all integer n greater than or equal to 1. So this completes video 63.